Hello. This video is going to be about molecular polarity. To explain what that means, though, I'm going to need to talk to you about electrical forces. So let me get started. This is going to be a quick review of electricity, electric fields, and electric forces. You don't need to memorize this for my class at least, but if you understand it, it'll make polarity a lot more intuitive for you. So there's this thing called the electric field. Positive charges will create outward pushing electric field lines, and negative charges will create inward pulling electric field lines. They create different kinds of arrows, pushing versus pulling, but that's not the only difference. They also respond differently to the arrows that exist. So for example, if I have a positive charge and I put it inside an electric field pointing to the right, what this positive charge will do is it'll sort of see these lines and decide to go in the same direction. So positive charges move with the field. Negative charges, in contrast, if I put it in an electric field, the same one, it's going to see these arrows, but it's going to do the opposite of what the arrows tell them. Just like a rebellious teenager. Just does the opposite. So this results in opposite charges attracting. So positives and negatives, they'll move towards each other. But if you have a negative and a negative, or a positive and a positive, they're going to move away from each other and repel. This is because of the fields they make. So imagine you have a negative charge and a positive charge. The positive charge creates outward field arrows, and the negative charge sees this arrow pointing to the left and says, no, I'm going to do the opposite of what you tell me. So it goes towards the positive charge. And that's why opposite charges will attract. But similar charges, if I have a positive and a positive, let's just think of the field lines. Positive charge creates outward pushing field lines, and as a result, this other positive charge sees the arrow pointing to the left and says, okay, sure, I'll go to the left. A similar thing happens with negative charges. So if something doesn't create or respond to electric fields, we call it neutral. And there are two different ways for something to be neutral. The first way, the easiest way, is for it to just have no charge at all, like it's a neutron in an atom. It just doesn't have any charge. Or it could have an equal amount of positives and negatives inside it, in which case it does have some positive and negative parts, but it's overall electrically neutral. If something has no charge, it won't respond to the field at all, and it won't move. If it has equal amounts of positive and negative charges, then what will happen is the positive charges will try to move with the field, the negative charges will try to move against the field, and they'll be tied, so it won't move at all. It'll be strained, but it won't slide in any direction. So electrons in the atom are negatively charged, and protons in the nucleus of the atom are positively charged. These are the actually existing negative and positive things in chemistry. I know that was a lot to remember, but the important fact is that protons will attract electrons, positives will attract negatives, and that atoms are overall electrically neutral because they have the same number of protons and electrons. So atoms overall are not going to slide around in an electric field.